Hello, hello, Mr. Walber here with 10.3 experimental and theoretical probability. Sounds kind of fancy, but it really isn't that bad. It says here experimental probability is based on trials of the experiment. You're actually testing to see what happens. Let's say I have a quarter, I'm going to flip it. I'm going to see how many times I actually get heads when I flip it 100 times or 50 times, whatever you want to choose. And that's exactly what this is. Probability of an event, number of times the event occurs divided by the total number of trials. So I flip it 100 times, let's say I got heads 60 times. Maybe I got it 55 times. Who knows? That's experimental, actually doing it. On the other side, theoretical is the ratio of the number of favorable outcomes to the number of possible outcomes. It's just a theory. Back to my quarter penny idea here. If I flipped a quarter or the penny 100 times, in theory, it should be 50 times heads and 50 times tails. The last slide was on experimental. That's actually doing it. So the difference between the two here is theoretical is what it should be, and experimental is what it actually is when you actually do it. All right, let's look at some examples here. It says the bar graph shows the results of rolling a number cube 50 times. So we take a die and roll it 50 times, and we want to know the experimental. So this is actual results of rolling it an odd number. Here, our odd numbers obviously are right here. So they rolled it 50 times, and this is what they got each time. So 50 is my total number of rolls. We have 10, we have 8, and we have, 11 that looks like. So I need to add all of those together. 10 and 8 is 18, excuse me, plus 11 is going to get me 29. So what is the experimental probability of rolling an odd number? 29 times out of 50 we got an odd number. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? Again, we're looking at probability. This one would be theoretical. Doesn't mean this is going to happen. It's just in theory. If it's done 2 out of the last 12, how many would you expect in April? Well, April has 30 days, so we have to calculate how many in theory it's going to rain. I'm going to go ahead and I'm going to cross multiply. 30 times 2 is 60. 12 times x is 12x. When I divide by 12 on both sides, these cancel out. X, I'm left with 5. So in theory, it's going to rain 5 times in April. That's theoretical probability. That doesn't mean that's what's going to happen. In theory, it should rain 5 times in the month of April. Another example of a theoretical probability, it says you randomly choose one of the letters shown. What's the theoretical probability of choosing a vowel? Well, let's start with how many we have. 1, 2, 3, 4, 5, 6, 7. So there are 7 total blocks. How many are vowels? Well, we have 1, 2, 3. So 3 out of 7 is my theoretical probability. Again, if I actually do it and see what I get, doesn't necessarily mean I'm going to get 3 out of 7, but my theoretical probability would be 3 out of 7. All right, last example problem here. It's a good one because it brings in both theoretical and experimental into the same problem. It says the bar graph shows the results of rolling a number cube 300 times. What's the experimental probability of rolling an odd number? We've already done something like this a couple slides ago. Here are our odd numbers. We have 48, we have 50, and we have 49. We rolled it 300 times. How many times did we get an odd number? When I go ahead and I add these together, 48, 50, 49 would be 147. So my experimental probability is 147 out of 300. I got an odd number. Now, this is where this is a great problem. B, how does the experimental probability compare with the theoretical probability of rolling an odd number? Well, let's think about this. If we have 6 numbers and we roll it, in theory, 1/2 of the time I should get an odd number. Obviously, when we found that, we didn't do that here. We did 147 over 300. So it was close because 150 over 300 would be 1/2. So it was close. but slightly less. We got a few less odd numbers than we did even. So our experimental and our theoretical probability were close, but we had a slightly less than 1/2 of the theoretical. Hope you followed that. We'll continue more of this tomorrow. Have a good night.